right, so today is the first day of our new module, Module 5, and it's going over more proportional relationships similar to what we've talked about a couple of modules ago, but we're specifically talking about scale factor and how this affects different shapes. So let's go ahead and read this problem aloud. Celeste drew an outline of a building for a diagram she was making and then drew a second one mimicking her original drawing. State the coordinates of the vertices and fill in the table. So first we're going to name the coordinates or label the points in our picture, going from the first picture to the new. So let's go ahead and label original and new. So I'm going to zoom in really close so that we can have some help seeing. I know that points are labeled X and then Y. So I'm going to go first to the X, which I see is 7, and then up 15, 16, 17, 18, 18. So that's 7, 18. I also see one, at 7 and then 0. I see one 11, 12. This is 13. 13, 0. And then 13, and it's the same height, so 13, 18. So there are the points of our original drawing. And now let's find the points of our new drawing. So I see the first one is at 7, 0. The second one is at 7, that's 9, so 7 up 9. I see 10, 0, and then that height must also be at 9. So now that we have labeled all of our points, the table on the right says that they want to know the height and length of the original drawing, or in other words, the height and the width of the rectangle in the first drawing. So I see that it is 18, let me use a different color, 18 spaces high. All right, so 18 spaces high. And it is, let's see, 1, 2, 3, 4, 5, 6 spaces wide. And now it wants to look at the second drawing or the new drawing to see what's the height and the length. So if I look here, I know that it is 9 spaces tall and 1, 2, 3 spaces wide. So now that we have that, what do we notice about the original and the new drawing? Well, first of all, I see that it is smaller. So we remember that we learned that word. This is a reduction. So let's go ahead and label that because it is smaller than the original drawing. But by how much? What would be the exact number that would show how we got from the first drawing to the second drawing? What do we notice is going on with the height and the length if we go from 18 to 9 or 6 to 3? Well, I notice that it's actually being cut in half. Or if we were going to pick a number to multiply by 1/2, and I can test that out here, 18 over 1 times 1/2, remembering to multiply across, gets us 18 over 2, and when we simplify, we get 9. Is that the same for half of 6? I see that we get 3. Yes, it is. So that means this number is called the scale factor. The scale factor is 1/2 because that's how we get from the original drawing to the new drawing, right? Or to the scale drawing. So the scale factor is 1/2, writing this down. We have also learned another word for this from a long time ago, which we call the constant of proportionality, because our scale drawings cannot be accurate unless we have a scale factor that we would use for every single point on the original drawing, right? So we would multiply every single point by 1/2 to get a new point in our scale drawing. Therefore, it has to be proportional. So that's why we call it our scale factor. We can also call it our constant of proportionality, and you will see both terms on your exit ticket. So let's make sure we write that down. And now we're going to try out another one on our own where we're going to label our points. We're going to label the height and the length and see if we can determine what is that constant of proportionality, what is that scale factor that takes us from the original drawing to the new. So here we go.